This video is going to take a look at sketching the graph of a rational function. Remember, we use the word sketch not because it's not going to have a lot of details, but because we're not going to make a gigantic table of values like we did with our inverse variation functions. We are going to look more at some of the major details of things that you can and cannot do, things that you can and cannot plug in, particular points that you know you're going to have, particular shapes that your graph is going to have. But when we actually draw the curves, we're not going to be as critical about getting every single little tiny point on the graph. So I'm going to go through this relatively quickly. I'm not going to spend a lot of time reviewing all the notes. You have the notes. If you do not have the notes, you can get them from somebody else. So what we're going to take a look at is all of the different things that we can find about this. First of all, the first thing I want to point out is notice that this comes from x squared minus x minus 6 factored out, x squared minus 6x plus 5 factored out. So one of the things I did is I went ahead and factored it for you, but you do need to realize that this still does come into play later on, this particular form of it. So we'll come back to that a little bit later. In fact, I'm going to take that and I'm going to move it over just a little bit on my page here so we can do a little bit of a graph here also. And that's not going to help too much, but it'll be alright. So, the first thing I told you is that when you are looking at these graphs, there are several things that we are looking for to see if we have any of these vertical asymptotes, horizontal asymptotes, if there are any holes in the graph, and x-intercepts, finding those things. So I'm going to do just a quick review, like I said, of each one of these things. The vertical asymptotes and the holes are very similar in the fact that they are numbers that you cannot plug in for x. So notice, first of all, as soon as I have this thing factored, none of these factors cancel out. And if you want to see what canceling out looks like, you can watch one of the other videos on simplifying or multiplying and dividing. And I may do another video on a graph that has a hole in it. But notice that nothing cancels out, so there are no holes in the graph because none of the factors cancel out completely. Vertical asymptotes are another one that you cannot plug in a value for. So they come from when the bottom of the fraction equals 0. So notice what would make the bottom of the fraction equal 0 is the same thing we did when we were solving quadratics when we set these equal to 0. If you set them equal to 0, you will get x equals 5 and x equals 1. That means you cannot plug in 5 on the bottom and you cannot plug in 1 on the bottom. So that causes what we call a vertical asymptote, on the graph. So once you find these things, if you are graphing one of these on the test, please make sure that you go through and you go ahead and graph them. If you know that you can't plug in 5 on the bottom and you know you can't plug in 1 on the bottom, then go ahead and graph a vertical asymptote at 5 and a vertical asymptote at 1. So we have a vertical asymptote here at 1, and then we have a vertical asymptote here at 5. So I'm going to go ahead and graph those as soon as I find them. Those are things that I cannot plug in, and very important, I cannot touch with my pencil, so it forces me to pick up my pencil on my graph. I'm going to skip down to the x-intercept now, because the x-intercept comes from the top of the function. Remember, the x-intercept is where the y value of the point is equal to 0. And so if the y value of the point is equal to 0, that means the whole fraction would have to be nothing. That would be the top of the fraction would have to be 0 to make the whole thing nothing. So what would make the top equal 0? If you look at this first one, it would be 3. Also, if you look at the second one, -2 would make it equal 0. Again, going back to those solving techniques we used with quadratics. So that means this graph is going to touch the x-axis at -2 and at +3. Those are technically the only 2 points on this entire graph that we know for sure our graph is going to touch. So finally, we have the horizontal asymptote. The horizontal asymptote, remember, is talking about the y values. So it's talking about the whole function, not just the top and just the bottom, like our vertical asymptotes and our x-intercepts. So when we talk about it, we're talking about what's happening with this division. And so what I told you to do was an easy way to do it is 3 rules. If the degree on the top is bigger, there's not 1. If the degree on the bottom is bigger, it's 0. If the degrees are equal, you divide the leading coefficients out in front. So notice this one is an x squared and an x squared. That's why I told you this would come into play later on. Notice that it is 1x squared and 1x squared. They're both the same degree. So this is 1 divided by 1. Our horizontal asymptote is going to be at 1. So we will draw a horizontal asymptote over here on our graph at 1. So now this is all the details that we have on our graph. This is the big details that Mr. Harrison is looking for. Okay? So this is the important stuff. This is the important things that limit where our function can be, limit what numbers we can plug in. So then the shape of it is just going to be a sketch once we figure out where our y values are going to be. So we talked about in class making this thing called a sine line. Essentially what a sine line is it is a line where it is the x-axis that you see right here picked up and laid down over here, where we label on this sine line our x-intercepts like -2, our vertical asymptotes like 1, our other x-intercept here at 3, and then our other vertical asymptote here at 5. And so what we're doing there is we're just labeling the things on our graph that we have to touch, the x-intercepts, or the things that force us to pick up our pencil, the vertical asymptotes. And so it divides our graph into these sections. So you have something happening on the graph here, something happened on the graph here, something happening here, here, and here. So we have 5 sections to our graph. And so what we do is we choose a number in between each one of those sections, and it tells us where the y values are, positive or negative. That's why it's called a sine line. And then we follow the asymptotes on the graph to make our curves and our shapes. So let's take a look at the first section. The first section is everything behind -2 or before -2. So what's a number before -2? It would be -3. So if you take -3 and you plug it in for x, 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 again, I'll say that again, we're plugging in -2 here, -3 here, excuse me, -3 here, -3 here, -3 here. It's going to give us a y value that is either a positive number or a negative number. And then we will take that and we will write that down, and that will tell us where our graph is located, and then we sketch it according to what the asymptotes are doing. So remember, we're only in this little section of the graph right here. We're not anywhere else over here. So we take -3 and we plug it in to see what it does to the y values. Again, you're not worried about what the actual y value is. You're only worried about the sign. So I gave you a little shortcut. I said just think of the signs. If you plug in -3 minus 3, that's negative. -3 plus 2 is still going to be negative, so that's a negative times a negative, which is a positive number. So you have a positive number on top of the fraction. Then you plug in -3 minus 5, that's negative. -3 minus 1, that's negative. So a negative times a negative is another positive. So positive divided by positive is positive. Again, we do not care what the number is. We just want to know what the sign of the number is. So what that tells me is that right here in this section of my graph, all of my y values are up here in the positive numbers. But I have an asymptote here that tells me that my positive numbers will run right up below that asymptote. They are not going to be way up here. It's going to follow the asymptote. Now remember, it could go above the asymptote and come back down to it. We don't know for sure because we're not getting a bunch of detailed points. We're just finding where the general area of the graph is. So then we go to the next section. The next section that I have is anything from -2 up until we get to this asymptote, so between -2 and 1. So a good number to plug in here would be 0. So if I plug in 0 here, I'm going to have a negative number. If I plug in 0 here, I'm going to have a positive number. So a negative times a positive is negative. Plug in 0 here, that's a negative. 0 here, that's a negative. So a negative times a negative is a positive. So a negative divided by a positive is a negative. So that means all of my y values in between here are negative. So it starts up here, touches this point, and then goes down below the axis. But again, it still follows the asymptotes. There's one here and there's one here. So it's probably going to make this little arch curve, just like we had on some of the other graphs, going toward that asymptote over here. But these are all negative values. Again, the negative and the positive doesn't tell me the shape of the graph. It just tells me where the graph is located. So we have the y values are positive and negative. And so then you just keep on clicking along. You go to the next section from here to here, from 1 to 3. A number between there would be 2. I'm going to take up the pace a little bit here, and we're going to look at 2 minus 3 as a negative. 2 plus 2 is a positive. So a negative times a positive is a negative. 2 minus 5 is a negative. 2 minus 1 is a positive. So a negative times a positive is a negative. But you have a negative divided by a negative, so that's going to be a positive number right here. But then we have to touch this point at 3. Then we go between 3 and 5, which would be 4. So if we plug in 4, 4 minus 3 would be positive. 4 plus 2 would be positive, so that's a positive times a positive. 4 minus 5 is negative. 4 minus 1 is positive. So that'd be a negative times a positive, which is a negative. So a positive divided by a negative is a negative. Again, guys, I'm doing these quickly in my head, but you can take your time and spend a little bit more time with those. So what it's going to be doing here is it's going to be positive until it touches this point, but then after it touches that point, it's going to go negative. So this graph, if you look at it, is going to have a shape that is up here following this asymptote, curve towards this point, and then go towards the other asymptote. Positive values, hit it, negative values. Positive, hit it, negative. So then we get every point that is over here after 5. So 6 would be a good one to plug in. 6 minus 3 is positive. 6 plus 2 is positive. 6 minus 5 is positive. 6 minus 1 is positive. So all of those values are positive, meaning all of my y values here are positive. So my graph will be way up here in this corner, but it's going to follow this asymptote and follow this asymptote. These graphs will always follow the asymptotes. So I may do another video that involves a graph with a hole, but it'll be a very, very quick video, maybe with very, very little explanation in it, because I want to make sure that I get to my family get-together tonight and spend some time with my family.